Anil Kumar, who is our technical product manager at Couchbase.
Hello, everyone. Good afternoon. I'm Anil Kumar. I'm a technical product manager at Couchbase. It's great that you guys are here. Welcome all. So today we'll be talking about the when should I use NoSQL, right? So this presentation, about myself. I work as a technical product manager here. Before joining Couchbase, I used to work in Microsoft. Worked in Microsoft for almost 8 years. When I joined Microsoft, I was a developer, and mostly I've been working on the database system, on the SQL Server. And then before I left Microsoft, I was working in Windows Azure, working on the SQL Azure stuff. And I saw that the industry was moving towards the NoSQL. A lot of things were happening here in the open source world. So decided to join the Couchbase. So it's been almost 8 months now working with Couchbase. Okay, so with that, let's get started. So today's agenda, so I've kind of, so we'll start with I'll explain about what are different kinds of database management system. So to see where we stand, so we have two different kind of database management system. Then we'll look at into what are the different, where exactly the NoSQL fits well, right? And then we'll look into the application requirement-based use cases. Finally, we look at some of the common use cases we have in Couchbase. So the two kinds of database management system. So we have OLTP or OLTP-like system, which is mostly the operational data stores. On the other side, we have the data warehouse or the analytical system, right? So the OLTP or operational data stores solves the big user problem. When I say big user problem, what that means is if your application is being used by millions of users, right? So if they are doing a lot of read-write operations, they are accessing your database continuously. So in that case, the operational data source is the one which they reach to, right? So if on the other side, which is a big data, if your application requires a batch analytics, or they're doing real-time, some heavy-duty like trend analysis, those kind of stuff, they go to the big data, which they have the historical data or archival data. They run long-running jobs to compile and do this analysis and generate the reports. So that's the two differentiations. We have the big users and big data. So we fit into the operational data stores. The analytical system is on the Hadoop, right? So to give you more idea, so let me add some more components to here. Traditionally, we had this, so we had OLTP or OLTP-like operational stores, which is basically the RDBMS or the other legacy systems, and the interactive web applications or mobile applications were built on top of them, right? And we had analytical system, which basically is, which are talking about the data warehouse or the RDBMS columnar stores, which did the all batch analytics or real-time, the huge trend analysis or finding insights or answers kind of thing. That was done on the analytical system. And the BI and reporting were the application which were built on top of that. And we had the ETL, the connector between the operational store and the analytical store, which transferred the data from operational store to the analytical store. So that's the how. So for example, your application is running on the operational store. Any historical data, we move that to the analytical system. We do batch analytics or do some trend analysis to generate some reports. So that happened there. So now we have started seeing that there is a lot of streaming data which is coming to operational store. So we have seen that many of the application now gets the live feed from Twitter, from Facebook, and from a lot of other social networking sites. So those data is coming into the operational store. So increasingly, what we are seeing is on the operational store, there's NoSQLs have been started using. They have started using NoSQL solutions. On the analytical system, we started using the Hadoop. The reason we started using the NoSQL on the operational store is because the data is not anymore structured data. It's more of semi-structured or unstructured data. So those fit well with the NoSQL, but it doesn't fit well with the RDBMS or traditional database management system, right? And again, the Hadoop is best fit for the big data. So again, on the analytical system, we started seeing Hadoop has been increasingly used on that side. To give you a big picture, so the NoSQL and big data, they kind of complement each other. So they go hand in hand. So for example, we have as I was just mentioned about big user and big data. So the big user, the Couchbase fits into the big user side, which is the operational data store. right? If the application requirements, if, for example, if you have building a web application or mobile interactive applications, which has the high performance at scale requirement, that fits well for the NoSQL. Whereas on the big data, which I mentioned about like data warehouse, where you have to, we want to get some answers or insights based on the historical data, that part is in the Hadoop. To give you some more idea on in terms of enterprise architecture, so what we are seeing more and more is like in big enterprises, before it was just the RDBMS data warehouse and the reporting and BI applications to get the data from there. But now we are seeing that depending upon the use cases, so some of the use cases fits well in the RDBMS still. Some of the use cases doesn't fit well there. So now they started moving to the Couchbase, which is a NoSQL document database, right? So you can see that both the systems coexist in the same architecture. So we have some of the data is in RDBMS, some of the data is in Couchbase, right? So depending upon the use cases, the application will get the information from both the system, and that's how the architecture has started evolving. Any questions so far? Okay. So we saw that we saw that where the NoSQL is used in a high level. Now let's look into the based on application requirements, based on use cases, where exactly the NoSQL is the best fit. So here are some of the application characteristics which are data-driven, based on the data-driven requirements. We see that some of the requirements here mentioned here are best fit for the NoSQL. So let's start with the first one. So the third party, if your application requires a data from the third party or user-defined structure. So what that means is if you have a dependency with the other third-party data, for example, in this example, Twitter feed. So if your application is built in such a way that it is dependent on the external data, in that case, you don't have control on the schema, right? So you are calling the Twitter API. If the Twitter API gets changed, then you have to go back and change your schema. So if you have deployed your application, I mean, if your data is stored in RDBMS right now, what would happen is like any change to the Twitter APIs, you have to go back and change your schema in your database. So and most of you know, in the relational world, if you change the schema, which is a very costly operation, you have to do the alter table operation, which is definitely which will bring. I mean, there will be definitely a downtime. So this kind of use case is definitely a best fit for NoSQL solution. So next one is supporting for unlimited data growth. So let's say that you are building a mobile app. It's a social app, which will, let's say, when you started this application, you have some few thousand users, but very soon, in next 1 month or so, you have millions of users. So there's a huge viral growth of your application, right? So in that case, what would happen is like you have to, if you are deployed on a traditional RDBMS kind of system, it won't scale to that well. So this kind of situation, like for example, in other presentation, we talk about Draw Something, which was an iPhone-based app, which grew from 50 users to 50 million users in 1 month, which was that was never possible in the RDBMS. Whereas in Couchbase, it's easy scalable, so you can add more servers and scale your cluster. So that's definitely a best use case for the NoSQL. Sorry. So for example, if you have attended the Couchbase introduction, Deepthi mentioned about it's very easy to add more servers to your cluster, right? So if you have a cluster of 5 servers now, and you see that there are a lot of users which are joining your application, you have started using your application, you can keep adding more servers to your cluster. So basically you can expand your cluster without any effort. In that case, even in case if you grow from 50 users to 50 million users, you just have to do is like add more servers to your cluster, and it's taken care. There will be no downtime. All the operations in our Couchbase is like all online operations. Okay. So if your application requirement is if your data coming to the application is a non-homogeneous structure, which means that every piece of your data which is coming in has a different structure. So for example, to give you an example, if you have a profile store, right, and if you store some profile information in a document, each profile has some different attributes. So let's say that my profile has Twitter ID, but the other profile has some other information. So to fit all these different structures, in case of RDBMS, what would happen is like if you store that in a table, that will create a lot of sparse columns, right? Or if you try to so if you store it in relational world, that would create multiple like sparse columns, and that will be waste of memory, waste of storage. Whereas in case of Couchbase, you can use the flexible data model, which is like JSON, which support JSON documents, where you can create each document can have a different structure entirely. So one document can have a different attributes, and the other document in the same database can have a different attributes. So we support that. So any requirement such as the data with the non-homogeneous structure is definitely a best fit for document database. So also we have seen that if your application is changing a lot, if there's a lot of changes happening to your application, if your data structure changes a lot, so that too it changes very quickly. In that case, even that case, if you're going to the relational world, there'll be like it's almost impossible for every time you have to bring down your entire databases for making the changes. Whereas in case of the document database, making those changes is like very simple. It's like since it's a flexible data model, we can have versioning on top of on top of your documents. So if your application is going to one version, if any changes happens to the application, it starts going to the next version, but in the same database. So it just all coexist in the same database. Also, we have started seeing that like variable length documents or sparse data records or hierarchical data, these are all data-driven requirements. They all fit well with NoSQL. So we looked at the data-driven requirements. Now let's look at some of the performance-driven requirements, right? So some of the customers from Couchbase, for example, the ad targeting is one of the use case. We support AOL and the MediaMind are one of the customers. So they have a requirement of the response time of 1 to 2 milliseconds, which is like entire when you make a call and then when you get a response back. So that's the response time that's like the low latency requirement they have. So that kind of requirement, it's only possible to have the key, when you store the data as a key value store and get the data as quickly as possible. That's the only way we can possible. If you store it as on a relational world, again, you have to do multiple joins to get the data back. It will never achieve that requirement. So on top of the other thing which we saw is high throughput, which is if your application has a requirement of 200,000 operations per second, or we have seen that as your application starts like writing multiple, if it's a read heavy or write heavy or mixed, where like start writing a lot of records to the database. Some of it's in case of RDBMS, it's not easily done. It requires a lot of effort, and then at some point it will start failing over. So that again we saw that it's a best fit for the NoSQL. So I talked about the viral application in the previous slide, which is like as your application starts growing, you can add in like large number of users. So you can basically scale your cluster. You can add more servers, and it can support that many users, right? And also unknown demand with sudden growth of users. Like if there is a lot of spike. So for example, in the Thanksgiving time or Black Friday, when there is a huge sales going on. So there's a huge spike of the users as well as like shopping carts, right? So at that point, at that point it's important to add more servers very easily. So you can expand. Like you need the elasticity of adding more servers, and at some point where when you know that that demand has come down, you can remove the servers. So that flexibility is possible in the NoSQL. And also predominantly direct document access. So for example, if you have stored your data in a relational world in multiple, so your data will be normalized and stored into multiple tables, right? So if you want to update a particular row, basically what it does is it has to do the row lock on multiple tables. If that same data is stored in a document, all the data related to that particular information entity will be stored in a single document. So when, in that case, what would happen is we just lock the document and we update the document. So whereas if it was a relational world, in that case, you have to basically lock multiple tables, that do the row lock on the multiple tables to update just one record. So again, that's again is one of the good use case for NoSQL. So as I mentioned, these are all the requirements which fits well for the NoSQL, and where the NoSQL is a good fit. So now let's look at some of the common use cases we found. So we have around 400 plus customers in production, and some of the very common use cases I have put together here. So, and I know today morning Yasin spoke in the keynote, and he explained about some of the use cases. So I'll try to go a little deeper and explain about what this use case means and what were the database features they were looking for, right? So one of the use case we saw is social gaming, right? So for example, the customers such as Zynga, Tapjoy, Ubisoft, Tencent, they use Couchbase to store the player and the game data in Couchbase. So what that means, like any player information or the game data will be stored in Couchbase. You can do some real-time analytics on top of your data. So if you want to find which player is at what level and what game he's playing, so you can create a materialized views on top of your data. So the data here, all the information here is stored as a document in Couchbase. So the next use case we saw is the mobile applications. So some of the examples here is Kobo or Playtika. The Kobo is a mobile application for e-reader. It's a digital e-reader application. And even the content of that digital e-reader is stored in Couchbase. So again, these customers use this Couchbase for storing the mobile app-related information as well as the content also along with that in Couchbase. So I explained about the ad targeting. So ad targeting requires a very low latency, high performance at scale requirement. And some of the customers such as AOL, MediaMind, Converto, they use Couchbase for storing the user information for fast access. So they need a 1 to 2 millisecond response time for all the requests. So the session store, one other big use case we've seen is a session store. Some of the customers such as Concur or Sabrid, they use Couchbase for storing the session-related information as a key value store in Couchbase. And this, again, I will go in detail about each of these use cases in later slides. But so they store the session information as a key value store for fast access, so fast retrieval. And I'll talk a little bit more on each of these use cases. So one other use case we are seeing is the user profile store. TuneWiki is an iPhone-based app which basically has the lyrics for all the songs, and they also have the personalization for the profile. So for example, if I open a new profile with them and I can select which songs I want to listen to and also have which lyrics to I can make them favorite. All this information about the profile that gets stored in Couchbase. So one of the advantage about storing the whole profile information in Couchbase is when you get the profile back, one particular profile back, you get all the information related to that. So you can know that whether who is this user, what are the favorites he likes, and what are the lyrics he listens to, and also you get all the information back. So that's stored in Couchbase. So High Availability Cache, I know the Orbitz is also presenting in this conference. So they use Couchbase as a cache tier replacement, what this means is they use the Couchbase as a in-memory object cache. They have this command center where so if you go to Orbitz now and look for the hotel information or flight information, all this information, you get the results back instantaneously. That's because of the Couchbase in-memory object cache. And I'll talk about that, what were the features we used and how we accomplished that. So one of my favorite is the content and metadata store. The content and metadata store, you can build a rich, this is an example of, you can build a very rich application, right? So here the McGraw-Hill, they're also presenting in this conference. There will be a presentation later. So they are building a online learning portal, and they use Couchbase as a metadata store, and also they use the Elasticsearch plugin. We built a Elasticsearch plugin for full text search. So so I have a couple of slides talking about the architecture, about how they designed it, what technologies are involved, and how they achieve this online learning portal. And I'll talk about the content and metadata store. Finally, we have this third-party data aggregation, so which is basically the Couchbase. Now increasingly, we started saying that Couchbase has been used for storing the social media or the data feeds. For example, LivePerson, they just spoke, I think, at 11 o'clock session. They talked about they use Couchbase for storing the live feed data, which is like the Twitter feeds or Facebook feeds or LinkedIn feeds, directly into the Couchbase store. So now let's go a little deeper into each use case, and I'll explain about what was this use case, what was the requirement, what data is getting stored in Couchbase, what were the application characteristics, what features of the database were used. So for the high availability caching, which I explained, the Orbitz is using us as for the high availability caching. So here you can, on the side, you can look at what data is stored in Couchbase. So in this case, they use us for the object in-memory object cache. So the data here is like application objects, popular search results, session information, heavily accessed web landing page. To give you an example, let's say that there's a long weekend and a lot of people are searching for particular flight information, right? So that flight information, because it gets queried again and again, they can store the whole query search results in memory. So any next request, they can serve it much faster. So on the other side, if you look at application requirements, they want to speed up the RDBMS because the RDBMS is the layer below us, the persistence layer, whereas the Couchbase is on the top, which is in memory, right? So they wanted a consistent low response times for document key lookups. And they wanted also the high availability, which is like in case if one of the server goes down, we want to have the durability. We will fail over to the another server, and that takes the traffic. And also they wanted to replace their caching tier. Their earlier caching tier was some third-party tool, but they replaced with the Couchbase. And also one of the things which I could mention is we have this, we are completely compatible with Memcached protocol. See, Memcached is, as most of you have been known, it's a in-memory object cache, which is very efficient, and any key value access, we have a sub-millisecond response time. So what are the features they use for the high availability caching? So they feature some of the features I mentioned about is like built-in cache, which is in-memory built-in cache, and also always-on operation. Since if you have attended the Couchbase introduction, they talked about all the operations on the Couchbase like happens in the memory first, and even once we have if you have set up the replica configured in a cluster. The replication happens in memory, so memory to memory, so that as soon as the data comes into one of the servers, we push it out to the other servers, so that if this server goes down, we have data somewhere else backed up. So that's all possible with the always on feature. And also all our operations like rebalance operation, compaction, all these operations are online. So if at any one point of time, your application will never see a downtime. So it'll all these active operational maintenance operations are taken care as a background online operations. So now let's look at the session store. So here, the data stored in Couchbase, in this case, it's not just the in-memory object cache, it's also the persistence. So we have both so one of the things which I can mention is like with the Couchbase, you get both the best of both worlds. You have in-memory as well as persistence. So they work hand in hand. So for example, if here you create, I think if you attended, so we have something called 1024 logical partitions, like we bucket, like we shard the data into 1024 logical partitions. It's the same thing in the in-memory as well as on your disk. So for example, if you have a cluster of 10 servers, those 1024 partitions will be split across. They'll be evenly distributed across all those 10 servers, right? And even in the in-memory, if any key comes in, it knows exactly which server to talk to and which server it has to go to. So that's all. That's the beauty of like you have the in-memory as well as on-disk persistence. So here the data stored in Couchbase is the session values like or cookies, such as so any session information. They can uniquely identify which session ID using the session ID. They can store the whole cookie in the Couchbase. Some examples such as like shopping cart, flight selected, search results. Those are all like session information. Those they will store in Couchbase. And the reason they do that is like application requirement. If you look like they had extremely fast access to the session data using the unique session ID, easy scalability to handle fast-growing number of users or user-generated data. So if so for example, at some point, as I mentioned, if let's say there is a long weekend or some big event. And if your application, there's a spike in the application, if there's a spike in the traffic, if you want to handle that, then you need the scalability. So that's available with the Couchbase. And also the always-on functionality I was mentioning about all the operations, all the maintenance operations are online operations in Couchbase. Some of the features they use here is again built-in object cache, which is for the low latency, fast response, sub-millisecond response time. Linear throughput scalability to grow the database as the data or the data volume grows. So there are a couple of benchmark reports from Altros and the Cisco, HP. They're all on our website. If you take a look, when you take a look, you'll see that as the operations per second keeps growing, you can add more servers, but it will be linear growth. You won't see a spike or it won't see a drop there. So you can, when you look at the benchmark, you will find that it will be a linear throughput scalability grows as the database or the user volume grows on the Couchbase. Also, we have the intra-cluster application also, and we have the cross data center application. So the intra-cluster application is mainly for the durability, right? So if you within the cluster, you can configure number of replicas, and all this replication happens, as I mentioned, memory to memory. So it's much faster, and we guarantee that your data is consistent. And also we have this XDCR, which is cross data center application. That's for the different use cases. So if you want to have a disaster recovery or a backup live cluster, or you want to have another geolocated data center in some other geo center, that can be supported with the cross data center application. And then that's also useful because if you, in this case, so for example, if your same application is running on the other geolocation, for example, in another locality, another place, so you don't have to, so first thing is like you can have an active replication going on between the two data centers. The same session information can be replicated between the two clusters, so they can be in sync. So any changes here can be replicated there. So it knows. So in that case, if the user logs in from this data center, he gets the same information, whereas the same user logs in from the another data center gets the same information. So it's always in sync. Sorry? The latency? So what we have seen is we have tested here within the United States, if we have a East Coast and West Coast data center, it's in 9 seconds latency. But depending upon what workload, we have different configuration in the sense, once you set up the XDCR, you can pretty much like set multiple options, multiple settings. One of the feature we shipped in 2.10 was optimistic XDCR. Basically, if you know that this data, basically what you are setting is a threshold, right? So if you know that you don't want to check on the destination center, on the destination cluster, if the same record is not there, you don't want to check, you can just optimistically replicate the data, which will improve your latency. In the sense, like it will be much faster than the before. And on another feature we shipped just today, like we released Couchbase Server 2.2 today. There's another feature which is like before the replication used to happen from the disk to the other cluster. It has to go through the HTTP protocol. But now we have something, when we replicate the data, it goes directly to the memcached, which is much, much faster. And we have seen that the throughput-wise, as well as the CPU utilization on the destination cluster, it has come down completely. Yeah. So here, I'll just quickly go through. Here on the use case was globally distributed user profile store. Some of the data stored in the Couchbase here is the profile, user profile information with unique ID, all the information about the user, such as the settings, preferences, his networks, his application state, all this information is stored in Couchbase. The requirements were like extremely fast access of the individual profile, always on system, like again, no downtime, flexibility to add the update user attributes. This is important to mention here because so let's say that I was mentioning before, if you have a user profile information, like each document can have a different structure. So the new document which we create, and it can coexist in the same database. The new document which we write to the database can have different attributes. So with that flexibility is achieved through the JSON document, and that's one of the beauty of document database, right? So you can get the flexibility to add any update to the user attributes, and your system will work fine. If it was the RDBMS relational word, you'd have to like alter the table, add new column, do all the changes to like accommodate that change. And also the easy scalability to handle the fast-growing number of users, which I talked about earlier. So some of the features we use, again, in-memory, built-in cache. We use the cross-data center application, which I talked about, which is active-active geo-distributed system, which is like you will have both the data center master, in the sense they can take read and write operation on the both clusters. And we have a conflict resolution between the clusters. So if the same key gets updated on the both clusters, we do the conflict resolutions to pick the winner, which key got updated recently, and we pick the winner. And also we have, I mentioned about all our maintenance operations are online. Data aggregation use case. So again, the data stored in Couchbase is all the social media information like Twitter feed, Facebook feed, LinkedIn, blogs, news, press articles. And the requirement was like flexibility to store any kind of content. So one important thing to mention here is like in the same database, you can have documents, you can have some blob, like key value store, you can have, so it's a combination of everything. So for example, to give you an example, let's say you're building an application and you have some structured data, but you have some unstructured or semi-structured data. All can coexist in the same database. And all that need is like they need a unique ID to identify which key, which and what value, and they can all coexist in the same database. So here we get the requirement was flexibility to store any kind of content, flexibility to handle the schema changes, full text search, and I mentioned about we have a plugin for Elasticsearch. So if you have a requirement for full text search capability, we use the cross data center replication technology for pushing all the changes from Couchbase cluster to the Elasticsearch cluster, where they get indexed and they delete the data there because they don't want to keep the duplicate data, but they will have the index. Any query comes, they go to the Elasticsearch cluster, get the IDs, get all the IDs back, and then they do a multi-get operation on Couchbase to get the document back. Okay. So some of the features they use for the data aggregation use case is like schema flexibility, which is very important, built-in managed cache, indexing and querying functionality. So we can create a materialized views on top of your documents. So if your data stored in Couchbase is a document which is a JSON type, then you can create a materialized views. You can do some real-time analytics on top of it. And also I talked about integration with Elasticsearch for full text search capability. And I think I have a couple of one more slide. So one of the use cases I was going to talk about was the content and metadata store. Here, so I can move on to the architecture. So the McGraw-Hill was, we're planning to build a online portal. And some of the things which so the problem they had is like when you're building a online portal with millions of users, right? So they want to have scalability. So they want to scale for like large number of users. And so they started evaluating multiple solutions. They ended up this is the solution. They experimented with multiple things like XML database, SQL MR engines, in-memory data grids, but finally, this is what they came up with. So these are the technologies involved in building their online portal. They have, on the back end, we have the Couchbase server with Elasticsearch, and they have the other, like the middleware on the front end, which is Zinky and Ember. And this is the architecture, how it looks like. So all their actual media itself is stored in CDN network, but the metadata information is stored in Couchbase. So as this metadata information comes to Couchbase cluster, we use the XDCR protocol to push the data to the Elasticsearch cluster. In Elasticsearch cluster, those data gets indexed. Basically, they index all the data and throw away throw the actual data. Any query comes from the application server, first goes to the Elasticsearch cluster, gets all the IDs back, and does a multi-get operation on the Couchbase cluster. And this is the whole architecture of how they have built the online portal structure. So if you're looking for, if you just search for a keyword called, say, Apple on their learning portal, anything related to the Apple, like any media related, like blogs or news articles, they just show up on the portal. Okay. Yeah. So any questions?
What is the main difference with the JBoss in stack?
I'm not sure about the JBoss, but the thing is, here we get both the in-memory as well as persistence, right? And also we have this, so we have, along with that, we have the durability, which is within the cluster, you can do the replication. And also from your database, you can have the cross data center replication. And we can create materialized views on top of this. And the whole system, the architecture is, so, if you have attended the introduction to Couchbase, sorry. So if you had attended the introduction to Couchbase, we talk about how you can create the indexes and how we have this indexing mechanism of like scatter and gather, where indexes only built on only the active data set. So it's not on the entire data set. And when we get a request, we basically scatter and then gather the request results and send it back. So I'm not sure about the JBoss, but I think we can look at, if the other, I can point you to the website, and now you can take a look at white papers. It's much more advanced. Okay. Yeah. So we are working with the, actually, so part of my job is like working on the ecosystem part, which is like talking to the partners and collaborating. So we are in touch with the Solar for building the Lucent plugin, but that has not yet started. So, but we recently had we built a technology partnership with the Gazang for security data on rest. And also we have a ETL integration with the Talend. So now you can push your data, Couchbase data from Couchbase server to any other data source like MySQL or any other, and in vice versa, you can pull the data from any data source to the Couchbase server. So we have this ETL integration with Talend. Yes, we have a Hadoop connector also. Yeah, and a bunch of our customers use Hadoop connectors where they have the, like as I mentioned about. So we have they have this operational data store, and then they can do some real-time analytics here in Couchbase. But for any batch analytics or trend analysis or huge in finding insights or answers on a huge data, those they push the data to the Hadoop cluster, and then they run those kind of operation there. Any other questions? Okay, thanks everyone.